Hello everyone. So today we are going to talk about this problem. Find first and last position of element in sorted array. Well, we are given an sorted array and we need to find a target value also. We are given, and now we need to find the first occurrence of that target value and the last occurrences of the target value. So in this case, this is 3 on front, which means first occurrences of this target value is 3 number position 0, 1, 2, 3, as you can see, and the last occurrences of this position element is 4. So we need to return that. And if we don't find anything, like we don't find the target value, or then we return -1 at those positions. Okay, so that is our problem, and let's try to solve this problem. So first solution that comes into our mind is obviously then like a loop, single loop, where we can go from left to right and right to left. We will run a loop, and as soon as we find the first value, we store that value into left index, and as soon we find the last value, we store it into the right index, and then we return this. But the question says explicitly here that you must write an algorithm with order of log n runtime complexity, which means, and the solution that we are having like discussing right now is order of n. So it will not work. I mean, the solution is correct, but the given time complexity is not right. So we need to find some other solution. Well, if you have solved this kind of problem like sorted, this should give you an idea. So where we get this sorted in non-decreasing order, which means the array we are getting, it would be in sorted order. So as soon as you heard the sorted word, there's an algorithm called binary search that should come into your mind right now. Okay, so now you are on the right track. You know that we can implement binary search solution somewhere, but traditional binary search won't work, meaning the binary search we need to modify it. For example, a binary search can give us the value, like yes, whether it will exist or not in order of log n time, which is true, but that is not what question is asking us to, right? It is asking us to the first occurrences and last occurrences of that particular target. So yes, the binary search is correct solution, but we need to modify it because we want first and last. Okay, so that is the solution that we are going to discuss. And first let me explain you how we will modify that solution, that binary search solution actually. So you know binary search how it will work, like it will divide the array into the half, and then we will search where the current index is the value that we are looking for. If not, then we will go left or right based on the requirement of the problem. Okay, so in this case we have to run 2 times. First, in the first trial, what we will do is that we will find the left index, and in the second time when we will run binary search, we will find the right index. Now how it will work, let's try to understand that. So you know the formula I plus j. First pointer will be at index 5 and last pointer will be index 10. So we will, and then we will find the middle value. Middle value will be somewhere like I guess 8. So when we will run first for the left index, like when we are trying to find the left index, what we will do is as soon as we when we will compare, like if the current value, whatever the middle value come, when we compare that it is equal to target value. If it is, then we know this is the first answer. Like we know that we found the target value in the array, but we just want to make sure whether this is the first value or not. So what we will do is we will store that value into the our answer left index, and we will move the j pointer to the mid -1. Like for example, this I think in this case 0 1 2 3 4 5 5 by 2 2, 0 1 2, then the middle value will be here, but let's just assume that this is here. So what we will, in this case what we will do is that we will store this index into the left index, and we will move the right pointer to the here. Now what it is saying is that I pointer is here and j pointer will be here. So what we are trying to say is that try to find the answer in this case also, like in this side also, in this particular region. If we found target value in this region, then we know that the answer we already stored, it is not the first one, right? Because there is one more occurrences in this side also. So that should be our answer. So we will update then. So what am I saying is that whenever we find the target value, we will move the j right pointer to the left side, which means mid minus 1, and the same algorithm will run. So if we found the greater value than target value, like for example this is where, so the target is 8 and the value currently we are is 10, so we obviously we will move right pointer to the left side, right? Because we know that the target value is can't be this side because this current value is bigger than the target value. So we know damn sure that the target value will not be this side. Basic binary search, right? And if the target value is, if the current value is less than target value, then we will move to the right side. This will work like a traditional way, but the only trick is this: whenever we find a current value is equal to target value in the left side, in the left index, when we are trying to find the left index, what we will do is that we will move right pointer to the mid minus 1. That's the only thing. And when we are trying to find the right, like right index, so what we are saying is that, let's just say this is where we found target value, but this time we are running for the right index. We want to find the right index, right most index, like where this is the last occurrences of. So let's just say this is where we are. I again will be at 5 and j again will be at the end of the where the 10 is. So we will do the like calculation of divide by 2, and then let's just say we are here. So what we will do is that, okay, 8 current value is equal to target value, so okay, we found the one value, great, store it in the right index variable that we made. And what we will do is that we know this is, but we are not sure that whether this is the last occurrences or not. So if you want to find the last occurrences of, then this is where I is, so we will move I to this side, because, and then what we are saying is that find, try to find the answer into this region also. If we found that there is also exist an element which is equal to target element, then we know that the occurrences that we found is not the rightmost. This should be, this current element or current position should be the like answer, right? So obviously then we will move to this side I, or in the right index. Remember, we are trying to find the right index this time, so that's why we are moving I to this side. And when we were finding left index, we were moving j to this side key. Okay, we found the value, current value, we store the index, but now try to find this side also. If there exists more value and it is equal to target value, then we know this should be the like leftmost index. So I hope you get to understand the problem. And like this is the little bit change that we made, like otherwise the same algorithm will run. So I hope you get it, and let's come to the solution now. Let me, this is the solution. So we made two variables, left index, right index. We stored by default them is equal to -1. We don't know whether they will exist or not, and then we run the traditional binary search. 0, length -1. I hope you know this basic binary search. Then we are dividing by 2, and we are checking if find the left index. This time in this algorithm, binary search, we are trying to find the leftmost index. So what we will do is we will check whether this current value, whatever value is equal to target value. Then what we are saying is that yes, then which means we found the answer. Then store this value into the left index, this index into the left index variable that we made, and move j to this side, move j to this side, because we are saying I know that this is the answer we are storing currently, but we want to make sure that there are no other. Think about this way, like if you could have gotten, then we know that the first time we we might be in here, then we want to make sure that this is the first occurrences. So in the left index we want to make sure, okay, we are here and this is this condition is true, that num current mid index is equal to target index, which is 8, but we want to make sure that this is the first one. So what we will do is that we will move j pointer to this side, which means we will put, then we have this region, and we want to make sure that inside also there's no occurrences of target. So but we know in this case we know that there are so many 8 like a target value exists. So we know this is not the first time, so we will keep updating until it reaches. So we will keep doing that, keep moving the j this side until we found that this was the last index, like there's no any occurrences of 8 into this left side. So that is exactly what we are doing by doing j mid -1. and other than that these are the same condition. If the current value is greater than target value, then we know that j mid minus 1, and if it's less than, then we will move to the I to the right side, and that's it. After this loop ends, there will be a value into the left index if it exists, otherwise it won't store. Okay, and same thing we are doing this, like let's just say we are doing the same algorithm. The only change is this time we are moving I to right side, because again, let's just say we are here. Okay, so we want to make sure that when we get here, we want to make sure that this is the last occurrences of the algorithm, like the target value. Okay, so for that what we need to do is that we need to go to the right side of it, because we want to make sure, okay, although we find the answer, but there might be some value that exists in this region also, so let's try to find it. And we again run the binary search for that. So that's exactly what we are doing. So we are moving I to this side in this gate for right value, and left value we were moving j to this side. That's it in this video. And I know that we are running two times this algorithm, still it is log of n, because it's two times, so 2 into log n, it's still 2, because we don't count the constant. Okay, and I hope, and I'm sure that if you found some clever way of solving it into one go, you can do that. But I'm sure, but it will be a little difficult for me to do that, so that's why I'm just doing it in a simpler way, so that you can understand the logic part of it. Okay, so I hope you get it. And yeah, that's it in this video, and I will see you in the next video. Thank you so much, guys.